Hello, everyone. All right. So before we get started, do you guys have any questions over what was covered last week or anything else in general regarding Java or this class? All right. Well, I'm going to jump into our topic for tonight. If any questions arise, again, do not hesitate to ask the questions. Going to be talking more about the user-defined classes and things and data types. And I just wanted to remind everybody that on the Tuesdays are the weekly Q&A sessions. It's entirely optional, so there's no requirement to come. But if you're struggling with a topic or you need help with the homework or something's just not working for you, it's a great time to stop by if you're available, the online chat session. It's really all about examples, so there's no formal agenda. It's just kind of me diving in and doing examples with you and just helping to clarify any topics that you might have. So, yep, well, next week, I'll be there. So if you're able to come by next week, and I did record it, I'm just now uploading it through YouTube right now, so I'll post it out there when we're done tonight so you guys can view the recording if you'd like. All right, so I'm going to jump in this and we're going to start talking about data types, variables, public statements, and constructors. Okay. All right, so what we're going to talk about tonight, classes, objects, and methods. So again, just reinforcing the same thing we did last week. We're going to construct an object. We're going to talk about accessor versus mutator methods, inputs and outputs, JUnit test case introduction, and the API documentation. So all great things. So some of this will be a review from last week, and then introducing new topic, and then like in week 3, we'll kind of go through it all one more time, and then week 4, we will hit the ground running in week 4. So be ready. Okay, constructors. So we talked about last week that a class is akin to a blueprint, right? It's not something that you can live in. A blueprint you can't physically live in, but you can use a blueprint to build a house. And so our class is our blueprint, and we're going to use our blueprint to construct or build an object. And the object is where we can actually store data. So we can keep things, or we can live in the object with actual data. So the whole purpose of that constructor is to build that object and to initialize the instance variables of that object. And the instance variables are the data. So that's the data that we're storing. Okay, so those are the things that we need to know about that particular object. So the whole purpose of a constructor is to initialize those instance variables to a default value. Now that default value might be something like 0 or a null value, or it might be an actual starting value that we want to start things equal to. Okay? All right. So the format for a constructor is it's going to start out public. So we have 2 choices here at the beginning. You can either define it as public or you can define it as private. If you're saying it's private, then what you're saying is only the object can use this particular method. Like no other programmer will have access to use it. Only inside the object itself can that particular method be used. But if you define something as public, then other programmers outside of the object can use that particular method or access that particular variable. Okay, so constructors are typically defined as public because you want to let other programmers create objects. So it'll be public, and then it's going to be the name of your constructor. Okay, and then we're going to have an open and closing parentheses, and those may or may not contain a value. If they do contain a value, the things inside of the parentheses are considered the explicit parameters. And these are values that you're passing to the constructor to use to initialize those instance variables, right? Now the constructor name is always going to be the same as your class. So we were working on creating like a pet class last time, or a dog class. So if the name of our class is dog, then the name of our constructor is also going to be dog. Okay, and again, explicit parameters, the arguments passed to it, and so they're going to contain values that could be used to initialize the instance variables. All right. When you're calling a constructor, so there's two different things that happen here. We define the constructor, meaning the blueprint that will be used. So we define the whole blueprint that will be used to construct that object. We do that in our user-defined class that we're creating. But in a completely different program, we're going to call that constructor. And in that program, when we're calling the constructor, we're actually physically creating the objects and everything else. So there's two different types of classes. There's the blueprint version of the class that defines how everything's going to work. And then there's an actual program with a main method in it that now is going to actually use that class to manipulate and create objects. All right, and I went over that a lot on Tuesday. So if that concept is still kind of fuzzy for you, you might take a few minutes to view the recording from Tuesday, and I think it will help clarify some things. All right, so when you're calling it to create an actual object, the format is the class name, because we're defining our data type, so class name, and then an object name equals new, a brand new object instance, then the name of your constructor, and then whatever parameters you need to pass to that particular constructor. So the class name is the name of your class. Like if we were creating a dog object, the name is going to be dog. The object name is whatever you choose to call your object. New is a keyword, so that will always be exactly the same. New will never not be old or used or anything. It will always be new, okay? The constructor name is also the name of the class. And then the explicit parameters. Those are the values that are going to be assigned to the instance variables. Okay, so for instance, we may have, so this would be defining a constructor. So this would be in a user-defined data type class, okay? So we could have public dog. The name of our class is dog, all right? And the name of our constructor is dog, so those always match. This one has nothing inside of the parentheses, okay? So this would be considered an empty or default constructor. It has no explicit parameters. And what it'll do is those instance variables will be set to default values, and those default values are something that the program designer would identify to you as the programmer. This is the default the default values for our instance variables, okay? The format for calling is going to be class name, object name equals new, constructor name, and then your explicit parameters. It's the same format every single time. It doesn't matter what user-defined data type you have, what object you're trying to create. This is the format you're going to follow. And so the name of our constructor is dog, which also happens to be the name of our class, right? So class name here, we have our class name is dog. An object name can be anything we want. We just have to follow the rules of the Java language, which we're going to talk about here. So we have temp dog, okay? Just a name I made up, okay? Equals new. It always has equals new. Then the name of our constructor, which is here, dog, which happens to be the same as the name of our class, so new dog. And then explicit parameters, but this one has empty parentheses, so when I call it, I have to call it with empty parentheses as well. So dog, temp dog equals new dog, open and closing parentheses, empty parentheses, and this would be the statement that I would put in my program, my main program, all right, that would create a dog object. So this up here would exist in my user-defined data type class called dog. This down here would be in a program that maybe is called kennel, in which case I'm storing a whole bunch of dog objects in my kennel. Okay, so a completely different program. This is one program, this is a completely different program down here. All right, So this constructor is actually an explicit constructor because it explicitly is saying these are the values I want to assign to my instance variables. So the beginning format is the same, public, because our constructors will always be public. Dog, the name of the constructor always matches the name of my class. Okay, but inside the parentheses, I'm defining some variables, some explicit parameters, some variables that are going to hold values that can be passed to this, and then I can manipulate those values. So the first value is data type string, and it's going to be assigned the name dname, and the second variable is data type integer, and it'll be assigned the name dage. Now, if I'm looking at this public statement and I want to write the constructor to call it, these variable names are irrelevant to me. Okay, I can't use them. This is inside of my user-defined data type. It's not available to me in my program. All right, but what is important for me to know is data type string. This first value has to be data type string, and this second value has to be data type integer. Okay, so I have to keep that in mind, and that there's two explicit parameters, and so I'm going to have to provide two values. So when I call this constructor inside of my program, my kennel program, or whatever the name of my program is, it's dog, it's always class name. So name of my constructor and my class are the same. So dog, temp dog, give it some object name. Doesn't have to be temp dog, it could be new dog, it could be dog one. It doesn't even have to have the word dog in it, really. Equals new, and then the name of my constructor is always the same as the name of my class, dog, and then I need to give it a string value, and I need to give it an integer value. So my string value here is Bruno, and my integer value is 3 for the age. Okay. Or what I could have done is I could have defined two variables, one called name and one called age, or whatever I wanted to call them, and I could have set my name variable equal to Bruno and my age variable equal to 3, and then I could have called this and said dog temp dog equals new dog and passed it the two variables, name and age. Okay, these would do exactly the same thing. Now what's likely to happen is when we're doing testing scenarios, we'll be creating our own data. So in a testing scenario, you'll do something like this. But when you're writing an actual program, you're not going to know what the values are. You're going to be prompting the user to enter the values. So you'll be using a format more along this line here. Okay. All right. So knowing that the format for calling a constructor is class name, and then an object name equals new, constructor name, and then your open and closing parentheses with your parameters. If we were to look at this constructor definition right here, public house with empty parentheses, what is the class name here? Yes, it is house. And what would be the constructor name? Yes, it's also house. Now, what are the explicit parameters? Yep, there are no explicit parameters because your parentheses are empty. And what would be a good object name if we were creating an object using this constructor? Those are all great. Okay, it's just anything that helps you to know that this is going to be a house object, you know, and it has to follow the rules of the language. So no spaces, no punctuation other than the underscore, starts with a lowercase letter, right? So those would all be great names here. All right, so to use this constructor, this is how it could look. Okay, house, new house, and I don't like my name here because then I go equals new house. But yeah, so we could substitute in the name of your house for any of these, you know, my home, our house, their house, main 1, 2, 3. Any of those could be substituted in here for this object name. And this is how this would look to call the constructor to create our object. And remember, this is in a different program. This is in the user-defined data type. This is in the program. All right. So we have this here, public customer, open paren. We have string cust name, comma space, double discount. So in this, what's the class name for this constructor? Yep, customer. And the constructor name? Yep. All right, explicit parameters. Yeah, we have two explicit parameters, one of data type string, one of data type double. The constructor itself is going to refer to those values by cust name and discount, but when we're calling the object, we don't have access to those variables. So you really don't want to get in the habit of thinking of these variables. Definitely think of it in terms of the data type string and double. Okay. And so this is what it could look like. You know, customer cust1 equals new customer. It takes a string value, which is Jones, and then takes a double value, which is 1.72. So this is what it could look like to call this particular constructor. All right. Now, in addition to constructors, which every class is going to have a constructor, there's also methods that could be in the class. And the purpose of methods, you can think of them as methods or actions or behaviors. The whole purpose of a method is to act upon those instance variables in some way. Okay, so it could be changing the value of an instance variable. It could be retrieving the value of an instance variable. It could be taking the value of the instance variable and manipulating it and doing something and coming up with another result. But it's going to act on instance variables in some manner. Okay, so there's two types of methods that we're going to have. There's an accessor method, which does not change the value of the instance variable. Okay, it's going to access the information and maybe use it, but it's not going to change the original value of the instance variable. So the state of the object remains the same. Then there's what's called mutator methods, and a mutator method will mutate or change the value change the state of an object. It's going to change the values of one or more instance variables. Okay. All right, so we got a question, is the method written in the class or is it written publicly and called in? So great question, Owen. So it is in the blueprint. So these methods are part of our blueprint. So they're part of the user-defined data type class, okay? So definitely in the blueprint. However, they are typically the methods are defined as public. Okay, so that anyone can use them. Now there's some methods that you aren't going to want to be public, and methods that you might want to define private, so only the internal object can access them, might be like an encryption program, like a password encryption, where you develop some sort of a hashing routine and you don't want other people to be able to get to that routine, right? You need to keep that private. So typically, methods are going to be defined as part of the user-defined class and public. All right. So again, we can define our methods in our user-defined data type, but we're going to call them in the class or in the program. Okay. So when you're defining a method in your blueprint, in your user-defined data class blueprint, the format is going to be, it can either be public or private. Most of the time it's public, okay? You're going to give it a return data type here if it returns anything. If it doesn't return something, it's going to have the keyword void. You're going to give it the name of your method and then any explicit parameters inside of your parentheses, okay? And I went through all that. All right. So an example, we might have public void set name and an open and closing parentheses, and in here we have one variable of data type string that the blueprint is going to refer to as in name. All right. So public, anybody can access it. Any programmers can get to it. No data is being returned. Avoid return data type. The name of the method is set name, so that kind of tells you we're going to be setting the value of something, so it's going to be like a mutator method. And then the value we've got here, this is the value you're going to be changing the name to. Okay, so this would be a mutator method. Looking at this, it's going to be changing the name to a new value. Okay. All right, so here's how that might look, or when you're calling a method, if it has a void return data type, nothing is being returned from it, it's going to be object name dot set name, and then we're passing in one string value, so Fred. So the first thing we're going to have to do is we're going to have to create an object, because all methods are called from an object. Okay, so we'd have to create an object first, and then we can call methods on that particular object. All right. Get name. So this type of a method is probably an accessor method. I mean, sometimes you can return data even from a mutator method. This one is going to retrieve the name, retrieve the value of an instance variable. What it's returning has a data type string, and likewise, it's also public. Okay. But it has no explicit parameters here. And so the format to call it, it is returning a value. So you have to put that value somewhere or you will lose it. It's going to return the value whether you put it somewhere or not. But if you're expecting to have access to that value to manipulate it or do things with it, you have to store it somewhere or you lose the value. So the first thing we'll do, we know it's returning something data type string. So we can define a variable string out name, whatever you want to call this, right? I just called it out name, equals, and then an object dot get name, and my parentheses are empty here, so they have to be empty here. And what happens is this method will get called, it will retrieve whatever it is that it's supposed to retrieve, and when it returns that string value, it puts it into this variable out name right here, and then you can continue to manipulate that particular variable and do with it what it is that you need to do. All right, so if we look at this particular example, public double compute average with an open and closing parentheses, what data type is going to be returned from this particular statement? Yeah, something in a double data type. Okay, so what's the method name? Yep, compute average is our method name. And what are our explicit parameters? There are no explicit parameters. So when we call this, methods will always have an open and closing parentheses. It's just a matter of whether they have a value in those or not. And so this particular method would have no value in the open and closing parentheses. Okay, so let's look at this one. Oh, we already did. And so this is how you could call it. Double average equals, and then you'll have created an object. You'll use that object name dot compute average with the empty parentheses. All right, so we've got this one, public void set number integer num1. So what's our data type that's being returned? Yeah, our return data type, is none because we have the keyword void. So nothing is being returned from this particular method. What's the name of the method? Yep. Set number is the name of our method. And what about our explicit parameters? Yeah, there is just one of data type integer, so you would expect to pass a whole number into this when you call it. And so if we were going to call this, this is what it could look like. Object name dot set number, and we can give it just an int. It has to be an integer, so 145 is an integer. Or we could have assigned 145 to a variable and then called it passing that variable. Either one of this would work. Yes, So the question is, does Java support overloading? And yes, it does. So what overloading is, and we actually just saw that with the constructors back at the beginning. So it's where your method name is exactly the same. So we have two set number methods, but our explicit parameters would be different. So we saw that with the constructor, where I had a constructor that was the empty or default constructor, right, with no parentheses. And then I had a second constructor that had the string and integer value inside of the parentheses, but they were the same name. So that's what's called overloaded. And what Java does is it looks at those explicit parameters, and when you're calling it, and it goes, okay, you're calling this method, but there's two of them with the exact same name. So then it looks to the parentheses and says, do I have a string and an integer? If so, I'm going to use this one. And if I don't have anything at all, then I'll use the other one. Okay? So, yes, great question. All right. Test-driven development. All right, so this is usually one that if you've been programming for a while, you don't like this at all. And I will admit, when I first learned about test-driven development, I didn't like it either, okay? So what test-driven development is you write your test cases before you actually write your code. And so the question always arises is, how can I test something that I haven't even written yet? And so we can look at it and we can go, what is the purpose of this method? Like, what's the whole point of the method? You know, is the point to change the name? Is the point to return the name? You know, what is it? We can identify before we've written the method what's going to be our input. What do I need to know in order to be able to do what I need to do in this method? So what's my input? We can say, what sort of action is this method supposed to do? And what is my output going to be from this method, if anything? Is anything coming back? And when you know those things, then you can go ahead and write your test cases ahead of time. And so I've got a great story for you guys as to why test-driven, and again, I have updates, but we will pick a time later. Okay. I really don't want to pick a time right now. All right. So back when I was quite the newbie programmer way back in the day, I was actually working at Columbus State Community College at that point in time. And I was writing some code for the registrar's office at that point. And so, of course, I had done such a spectacular job of writing my programming, right? And so I had made these modifications, and I went over to talk to the users of the system. And I'm like, all right, I've written your program. Here it is. I want you to test it. You know, let me know what you think. You know, of course, I've tested it, because any good programmer worth their salt tests their code, you know. And so I had tested out, and I just knew they were just going to be so flabbergasted with the wonderfulness of my programming. And so I went over there. They were in a different building than we were. I brought up my program, you know, showed it to them, asked them to test it. Before I had even managed to walk back to my office, they had managed to break my program. And what it was is they had like pressed, I don't know, an F6 key, which served absolutely no purpose in my program whatsoever. And so I did not handle the pressing of the F6 key. I did not take that into consideration, and so my program crashed. Because why would you press a key that serves no purpose? And so what I had done when I had tested my program is I tested it based upon how I had written it or how I expected it to be used, not based upon all the possibilities that could have happened. And so if I had written my test cases before I had written my code, I would have said, well, what if they do this? What if they do this? What if they do this, right? And I would have had much more robust tests, because I wrote my test cases after I wrote the code, I tested specifically how I thought the program should be used as opposed to anticipating how it could be used. And so that's my little vignette for why test-driven development is a good thing. Okay. So let's take a look at how this might work. So we have this statement in a user-defined data type class, right? We have defined this particular method, public void set name string in name. So we can look at the Java docs. to get a description or a purpose of the class, or you can look at the design information. We're going to take some time to look at some Java docs here in a couple minutes, all right? But we can, look at the design specifications for the program or look at the Java docs to get a description. And so we know the whole purpose of this is to set the instance variable name to a brand new value. We know what our input is. We can look at our explicit parameters. So we've got a string data value coming in, and we can look at our output there, and we see it's void. There's nothing returned. So, and we would expect that it is going to modify the name. So if we were to call this particular method, we know we have to pass it a value of a name, and what we would expect to happen is after we've called it, that the name would be changed to this new value, right? So what we can do, so what we know is the purpose is to change it to the name to a new value. We know that that name is stored in the explicit parameter in the variable in name, right? We know if it's working correctly that the name will be changed. When it's all said and done, after it's finished, the name will be changed to the new value. All right, so when you're going to write a test case, and you're going to write a lot of them in this course, okay? You're going to do it the exact same way every single time. The first thing you're going to do is you're going to create an object. Every single time you're creating an object. Next, you're going to do any setup work if needed. This is the only step that's optional. Sometimes you need setup work and sometimes you don't, okay? But if you do, this is where the setup is going to fall. Then you're going to call the method that you're testing. It doesn't do any good to do all this test stuff if you never call the method itself. So you're going to call the method that you're testing, and then after you call it, you're going to check to make sure that it did what it was supposed to do. Okay, these 4 steps, which number 2 being optional or dependent upon what it is you're testing, every single time, these are the steps you're going to take. And so if on a test I were to ask you, what are the steps in test-driven development? You're going to say, create an object, do any setup work, call your method, make sure it did what it was supposed to do, okay? So, step 1, create the object. So if we're looking at a dog, we've got a method that we're testing in a dog class in our dog blueprint, and this is the constructor to create a dog object. We're going to create that object. So it has 2 explicit parameters. Constructor name is dog, meaning the class name is dog. So we write the statement to create our object. Step 2, do any setup work. I'm going to be changing the name of my dog. So originally the name of my dog is Spike. When I created the object, I'm going to be changing it to Spot. So I created a variable here to hold the value Spot. So that's my setup work. 3, call the method that I'm testing. I'm testing this setName method here. So it doesn't return anything. It's setName, and it's expecting a string value as the explicit parameter. So here's the object that I created, temp dog. Here's my variable containing the value I'm going to change it to. So temp dog, it's always from the object name dot method name and then the value here. So temp dog is my name of my object dot setName, and new name, my new name variable contains the value of my new name. I could have just put Spot in here as a string literal, or I can use the variable name, either one. So step 3, call the method I'm testing. And then step 4 is make sure it did what it's supposed to do. And we're going to use one of these assert statements to check that out. And so we have a few different ones. This one will be the one we use the most often, the assert equals. With the assert equals, we say this is the value I'm expecting, and this is the actual value that I've got. Okay, this is the one we'll use the most often. There's also an assert null or an assert not null. We will use this assert not null when we're testing constructors. And then there's assert true and false, which we'll use with Boolean statements, but that's a little bit down the road. So in this case, what we'll do is an assert equals. I'm expecting Spot because that's the value I gave it, so I'm expecting it to now contain a value of Spot, and I'm going to call my getName method to retrieve the value. So on my same object here, my temp dog, I'm going to call the getName method to say, all right, get the value of my instance variable and compare that value against Spot And if they're equal to each other, then I pass. My test case passes and everything worked the way I wanted it to. But if they're not equal to each other, then I've got a problem. Something failed, something didn't work correctly, and I need to go to my program and figure that out. Okay? So, step 1, create the object. And I created it with a name of Spike and a value of 2 for the age. Step 2, do any setup work if needed. And I just kind of created some setup work for you guys here with assigning this variable. That was optional. Step 3, call the method you're testing. I have to call it on my object, tempdog, that I created, tempdog.setName, passing it my new value spot. Step 4, test to make sure it did what you were expecting. So you retrieve the value here and compare it against what you're expecting. And if they match, you pass. And if they don't, you don't. Cases like the F6 key. So this is a really simplistic case here. Oh shoot, I just drew a blank. So in some test cases, what you're going to want to, so let's say I'm setting the gender of the dog. So I'm going to set the gender of the dog to either male or female. Well, I would want to test it passing. So I would want to do like 3 different test cases, right? Because what are the possibilities, or maybe 5 different test cases. So if I was setting a gender, what are the different possibilities that could happen? So I could set the gender to a male or to a female or to an invalid value, right? So I would want to test, all right, if I'm setting it to male, did it work correctly? And then I would want to test if I'm setting it to female, did it work correctly? And then I would want to test, I set it to Fred, did it work correctly? Because it shouldn't let me set the gender to Fred, right? So that's what these test cases that I'm showing you here are pretty simplistic, and that's what we'll start out with too, is real simplistic things. But we'll get into a lot more complicated test cases where you need to consider all these different scenarios, like male, female, and something else, or maybe an age is, only certain. I can't remember if we're doing insurance. We'll be doing a lab scenarios here, and I can't remember which one you guys have for this semester, but there'll be a lot of different scenarios, and you'll have to test for all of those different cases. So yeah, but the F6 kind of a key, we're not going to get into that in this class, but you would have to kind of sit down and go, all right, what's all the different things that could happen? And knowing that the F1 key would be help, and this key has this purpose and this key has this purpose, you'd want to say, well, they could hit any other key. I'd probably want to trap all other keys, then display error message kind of a thing. All right. If we take a look at this particular method, the set breed, again, it doesn't return anything. It's void return data type. The name of the method is set breed, and it has one explicit parameter, data type string, that will contain the new value of the breed. So again, the purpose is to change the breed to a new value. The new value is stored in the explicit parameter. And if it's working correctly, we would expect the breed of that particular object to now contain this new value. Okay, so again, exact same 4 steps. Create the object, do any setup work, call the method, make sure it did what it was supposed to do. Okay, so create the object. We're still working with our dog here, so I just went with the same object, our same call for the object. The breed is not specified here, so it's going to have some sort of a default value, perhaps unknown, perhaps null. Okay. Do any setup work. So here I chose to have a variable to set it to poodle. Call the method that you're testing. So tempdog.setBreed equals new breed. And then check to make sure it did what it's supposed to be. So I do assert equals. I'm expecting it to have poodle, and I retrieve the breed. So I call the method to get the breed from my object, and I compare it against the value poodle, and if they match, my test case passes, and if they don't match, then it fails. All right. So API documentation. So Java docs are actually an amazing thing. And I went over that on Tuesday too. So you can actually see how the Java docs can be generated from your code. All right. But Java docs will let you view all the information about about classes. So you can see them out there. You can see, like, you'll be able to use them with the labs and things that we work on, but you can also see all of the classes that Java provides. And somebody asked me about that last time. So if I can click on this or not, oops. Okay, let me just end my slideshow or actually just let me. Okay, so you can actually just come up here and type in Java docs, okay? So I'm just in Chrome. And it's an Oracle Java doc, so you can click on that. And it'll come up, and here's all the different packages that are available in Java, and here's whatever package you've clicked on here. Here are the different classes that are available. Okay, so we have a question. Will you test the string for user errors like tempdog.setNameSpot? You'll do some testing, but we're not going to get into a lot of really detailed validation entry testing in this class. That's actually in Comp 121, where you're going to take your test cases to the next level. So we're going to kind of stick more simplistic. It won't seem simple in Lab 3, but we're going to be more simplistic. And then in 121, they get into error checking and all of that sort of stuff. So, all right. So in the Java docs, up here is your packages. Down here are all the different classes. And if you wanted to see what was going on, then you can, I'm trying to find the string class because we use that all the time. So you can come down here and then you can click on this. So here's the string class over here. So you can click on it here. It tells you it's the string class. If you scroll down, it tells you the different constructors. So these are the different ways that you can create string objects. All right, so it gives you a whole bunch of information. And then here's all the different methods that are available in the string class. So we have an index of right here, index of string. And so if you click on that one, then it tells you it returns a value, a data or an integer value. The name of the method is index of, and you put a string in here. And so what it does, it returns the index within the string of the first occurrence of the substring. So you might have a string hello world, and you're looking for LL, and it'll tell you LL begins at position, whatever that is, 2 in this string. And I'm going to say it begins at position 2 because you start counting with 0. So the H is 0, the E is 1, and the first L would be 2. Okay. So you can come in here and you can use this to look at all the methods that are available to you for the string class. So if there's something that you want to do, like you wanted to convert your string into all uppercase, you see here's a to uppercase method. You can click on it. You can read about it. You can see how it could be, what it's expecting, if there's any explicit parameters, if it returns anything, it returns a data type string, what it does, and you can get an idea. So the Java docs will be lifesavers to you in this class. So you can just keep in mind that the Java docs are available out there. All right, Lab 1. So Lab 1 has been distributed out on Piazza, and I have not downloaded it yet, which is really bad. All right, we have 12 minutes. Let me go to Piazza and download it really fast so I can upload this for you guys. Okay, so this is exactly what you do. You go to the extra credit in week 1, click on the extra credit icon, and then click on the open button up at the top. You'll be able to come out here to Piazza, and you will go to Lab 1. Where is Lab 1 up here? Oh, why can I not see the different stuff? Week 1 clarification. Okay. I want to get to Lab 1. but I don't want to create a new post. Oh, there we go, lab 1, sorry. Okay, lab 1. You'll click on the lab 1 distribution. There's a description here that you can download. Okay, and then there's also the data files. All right. So this description here contains a lot of fluff. So what it's supposed to do is represent to you what you might encounter if you're working, with a user. And, have you ever talked to someone and like they're telling you all this information and you're kind of like, just tell me what I need to do. You know what I mean? Like, just stop telling me the extra stuff. Just cut to the chase here, but they're giving you a lot of extra things. And so there's a lot of extra stuff in this description that you may not need, and so you'll need to cut through all of that stuff. All right, so this is 2018 summer. Oh, that's what my problem is. All right, this was lab 1. I am not getting into the, sorry guys that you're having to watch me type all this stuff. All right, got that saved. Okay, so when you're downloading the files itself, these are zipped. And while, they'll now let you like look at them and you can open them up and you can see the different files and things, you can't do anything. Like you can open it up in BlueJ, but you're not going to be able to save or anything. So you need to extract. So the first thing you're going to do is extract it, browse to a location, store it somewhere out on your hard drive, select a folder, place that you're going to know. Don't put it in the temporary folder, it'll all disappear as soon as you're done, and extract all of your files. Okay, and then you'll have a folder here. Inside of this folder are all the package files. But when you're opening in BlueJ, you're going to actually just open your project. So you're going to navigate to that folder that you just created, and then you'll see a file that looks like this, which is your student distribution, and then you can open it up and you're going to find your lab inside of there. Okay, so your lab will contain some opening files. All right, so the whole purpose of this first lab is to introduce you to BlueJ, introduce you to WebCat, introduce you to the format of the labs. So what we're doing with regards to this lab is it's 90% complete. The code is provided, but there are both syntax and logic errors that exist within the code. Okay, and it's going to be what you have to do is you have to find and correct the syntax errors. Once you've found and corrected the syntax errors, you're then going to run the test cases. So you'll have to write a few of the test cases, but most of them are provided for you. You'll run the test cases, which will then identify for you some logic errors. Then you'll have to find and fix the logic errors. Okay. Once you've got everything done, then you're going to submit to WebCat, and WebCat may find some additional errors for you. Okay. So you'll use WebCat as a tool. WebCat is not a one-time submission. You can submit to WebCat one time or 100 times. I don't care. Okay. It's a tool to help you gain the maximum points possible on the lab. So when you submit to WebCat, it may identify poor coding style, and it deducts 1 or 2 points for every one of those guys, which you can then go back to your lab and correct and then resubmit. Or it may identify for you some errors in the logic of your program, because your program may be compiling fine and it may pass all of your test cases, but maybe you didn't write robust enough test cases. And so what happens is WebCat actually runs instructor test cases against your code. And as long as you pass our test cases, then your code is considered logically correct. All right. So WebCat will also identify those types of errors for you as well, and you're to use the hints and things that WebCat gets you to achieve the maximum points possible. And they change it every single time. So it's either 60, I think it's 60 out of 70 points is the maximum that you can earn. And then I, as the instructor, will review your code manually and award the remaining 10 points myself. Okay. All right. You do not have to use BlueJ. Like if you're using a different IDE, if you're using Eclipse or some other development environment, what you're going to want to do is, oh, where did that go? You're going to have to copy things to a zip folder. So if we were in this, oh, I'm back in this, you're going to want to copy all of this stuff. Or you could just copy, you know, at the one level, the folder and drop it into your folder. But you're going to need all of this stuff that's inside of here. Really, if you just took the, I hesitate to, WebCat is going to compile your code. So you have to provide both the compiled version and the Java version. So you would need at least the class and Java files. The only one you don't need is the demo. But you need, in this case, you need the player and the player test, but you would not need to upload the demo stuff. You do need the readme.txt file. Okay. So hold on here. We're going to go back to, okay, so just general questions. And then I'm just going to do a quick 10-minute or 8-minute review of the lab itself. And then on Tuesday during the Q&A session, I'll go into a lot more detail in the lab, which of course will be recorded. So if you're unable to make it on Tuesday, then you can certainly watch the recording there. Okay. But any other questions, guys, don't hesitate to pop them up there or shoot me an email, post them to Piazza. All right, so your scenario, John Golf, which ironically, we're going to be doing a golfing scenario. Okay. He is the Chief Information Officer of Foresight. And he is going to be blah, 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 blah. Local golf tournaments going mobile. They're going to have spotters on the golf course. How apropos with Murfield just coming up right around the Memorial Tournament, right, next week. So spotters on the course are going to be using smartphones to wirelessly report on the performance of golfers as they progress through their 4 days of competition. 4 rounds of 18 holes each. A Java application that collects and processes data coming from the spotters on the course. I asked some questions about test-driven development, which you guys are all now experts on that since we just went over it. So you're going to review and fix a prototype application for managing the scoreboards placed around the course. All of this stuff. So the prototype consists of a Java class called player. So the very first thing you're going to do is you're going to be modeling a player. So you're going to create a user-defined data type of player. And then we're going to be testing it using a player test class. And get this highlighted here. So those are the 2 key things right there. No interfaces. It did not even compile, so there are both syntax and logic errors. Okay. The test class is incomplete, so there's going to be some things that you're going to need to do in the test class itself. So this is all key. This would be, so all that stuff at the beginning might be fun to read and stuff, but now we're getting to the information here. Okay, a tournament golfer is modeled as followed. So this is going to be your instance variables that you're going to have inside of your player class. You have the name of your player, which is going to be text or string data. The holes reported for the player, so maybe they've played 7 holes or 12 holes, okay? Total strokes for the player, so a positive integer number or non-negative, and the player's score relative to par, which is also going, it can be negative, 0, positive. So they may be 3 under par, so it would be -3. They may be 5 over par, or they may be at par, which would just be 0. Okay. How many of you guys are thinking, oh my gosh, I am not a golfer. I don't know what any of this means. Is anybody like, I hate golf? Um, and that's okay, because as a programmer, we become the experts in the field in which we have to write at, right? I was not a healthcare worker, but now I work in a health environment, and so I've had to become the expert of that environment. So you adapt yourself to work in whatever environment you're in. All right. There's going to be a constructor for creating an instance with a string parameter naming the player, so an explicit constructor. And it should set the other instance variables to 0. So that's going to be the default. It's going to provide us with the name of our player, but the holes reported, the total strokes, and the player's score is going to be 0. You're going to have a setter and getter method for the name of for all of these. So that would be an mutator method, a set method for each one, and then an accessor method or a get method for each one of those instance variables. There is also another method called report score, which reports a whole number, par for the whole, and the player's score on the whole. Okay. And then get percentage completed, so it will tell us how many of the holes have been completed. And then a toString, which is an output method, and it's going to output things in this format. The name of the golfer is, whatever the last name of the golfer is, and then what their score is relative to par after 12 holes. Okay. All right. So the key is you're provided with a project file, which is what we saw here. Okay. You're going to need to find these errors in the project file, correct them, and move on. Now, so to look at this demo file, you can ignore that guy. This is an actual program. It has a main method in it. It's 100% correct. There's nothing that you need to do to it. It's there to give you some visual satisfaction, all right? These are the two guys you're going to be working with here, which is the class. This is our user-defined data type, our blueprint right here. And this is the test class that's testing everything in this class here. And then this guy is a program that you can run that will create objects and manipulate them and then provide you with some output. Okay, so this guy is right, and you're more than welcome to run it and see what goes on with it, but you don't have to do anything with it, and WebCat does not grade this at all. For these two, this is where you're going to be working. So in here is the blueprint that will be used to create objects. Okay, so this is your code for the blueprint. You're definitely, yes, you are going to have to compile these. You'll compile all of them. And then this is your test case here. Now, we only have 4 minutes, so I'm not going to have time to go through any of this code tonight, but definitely on Tuesday I'll spend some time, and then if we have time next Thursday, I'll do it as well. But what you're going to come in is you're going to come in right away, and you're just going to compile. So you, up here at the top is a button, compile. So this is the blueprint class right here, so you compile it, and right away it's going to tell you, oh, you're missing a semicolon on this line. So you fix your semicolon, right? And then you compile it again. And it'll tell you a different error, and you'll fix that error. And you'll go on until eventually you have no more errors at all. In the test class, there's going to be some lines here. Let me see if I can make this bigger. So this is all finished. This is finished. But there's going to be some lines in here that are going to say, here, test whether the instance variables were, so replace 999 with the corrected expected value. So you're going to be fixing these values right here. And somewhere else it probably says the same. Replace the assert true below with another test case. So you're going to be replacing this one with a correct test case. So you're going to fix these two things in here and then compile this one. And the goal, of course, is they should both successfully compile. When you're all done and they've successfully compiled, then what you're going to do is you're going to right-click on this this test class after it's successfully compiled, and you're going to click this Test All button, and it's going to run through all of those test cases. Let me see if I can pull up last semester's lab. This is not the right one that I want. Here we go. Oh, I need to pull this up in BlueJ. All right. So this is a completely different lab. They worked with rat racing last time. You're going to be doing golfing, but same basic format. They had a driver, which is the same as your demo program. They had a rat class. You're doing a player class. And they had a rat test, and you're doing player test. All right. So this has been corrected. All the errors have been written out. And this one, we've actually fixed everything here. But you'll right click and you'll do a test all. It's going to run through all the test cases. And if they all pass in green, then you're good to go. If any of them don't pass, there'll be like a red X in front of them, and then you can click on them, and it'll give you some output down here at the bottom to tell you what it expected versus what it got. And then you'll have to go investigate. And so if it didn't pass, then you would come in here and you'd have to look at the code and try to figure out why it didn't pass. What about it made it didn't pass? And then you have to fix, and so that would be a logic error, and you'll fix the logic errors. And you'll keep going back and forth with that process, correcting your logic errors, compiling it, running your test cases until eventually all of your test cases pass. Okay? All right, I'm going to stop right there because we hit 9:30. Now, if some of you are like, oh my goodness, I have no clue what's going on here, don't worry. This is week 2, and the lab is due, I think, Wednesday of week 4, but let me just double check that. June 6th. So yeah, June 6th is not quite 2 weeks away. So you've got 2 weeks to work on the lab, which is plenty of time. I'll definitely go over it on Tuesday during the Q&A session. If you can't make that, that's okay. It'll be recorded and you can refer to it. I'll post it out on Piazza so you can always watch the recording. And if we have time next Thursday, I'll spend some more time going over it as well. So at this point, focus more on your homework and understanding what's going on there. And then definitely next week is when you'll want to start working on the lab. All right, so I'm going to end there. Lots of stuff. Sorry, guys. Do you have any questions? Anything else for me before we end tonight? All right, well, certainly if anything arises, you can email me or send them out to Piazza. Have a great weekend. Enjoy your Memorial Day, and we will see you guys next week.